Good evening. మహాగణాధిపతే చాలా దూరంగా ఉంది. చాలా దూరంగా ఉంది. Yeah, good evening, children. Good evening. Mahaganadhipate. We are discussing problems on polynomials, finding the zeros, and after that finding the relation between zeros and quotients. Ax square plus bx plus c is the general form of a quadratic polynomial where a, b, c are real numbers and a is not equal to 0. There are other two forms. One is ax plus b, the another one is ax square plus c. This is the general form, and these two are also quadratic polynomials because highest exponent is 2 only. Okay, so for this polynomial zeros are x is equal to plus or minus root over minus c by a, and for this polynomial zeros are 1 0 is 0 and the other 0 is minus b by a. Okay, now so what is the relation between zeros and quotients of any quadratic polynomial? Suppose alpha comma beta are zeros of ax square plus bx plus c. If they are the zeros of ax square, alpha comma beta are the zeros of ax square plus bx plus c, then sum of zeros equal to minus b by a and product of zeros equal to c by a. This is the relation that exists between zeros and quotients of any quadratic polynomial. We have observed that one also. Let us take an example. Let us take an example. 5x square minus 4 minus 8x. We need to find out the zeros of this polynomial, and after that we need to verify the zeros of the relation between zeros and quotients. First write the given polynomial in the general form. Write the given polynomial in general form first. Then split in the middle term. Minus 20. So 5x square minus 10x plus 2x minus 4. So negative 8x we can split like this. Negative 8x we can split it as minus 10x plus 2x. And minus 10 into 2 is negative 20. So from the first two terms we can take 5x common, remaining is x minus 2. And next two terms we can take 2 common, remaining is x minus 2. So x minus 2 and 5x plus 2 are the factors of given polynomial. These two are the factors of given polynomial. Now 2 is the zero of this polynomial. Minus 2 by 5 is the zero of this polynomial. But these two are factors of this polynomial. Automatically these two are zeros of the given polynomial. That is what we have to write. 2 is 0 of x minus 2. Minus 2 by 5 is 0 of 5x plus 2. But x minus 2, 5x plus 2 are factors of 5x square minus 8x minus 4. 2 is the 0 of x minus 2. Minus 2 by 5 is 0 of 5x plus 2. But these two are the factors of this polynomial. Then automatically 2 comma minus 2 by 5 are zeros of 5x square minus 8x minus 4. This is what we have to understand. And after that, we need to verify the relation between zeros and coefficients. Consider zeros and coefficients. Let alpha 2 and beta is minus 2 by 5. A 5, B negative 8, C negative 4. We are considering zeros as well as coefficients. Now, calculate alpha plus beta and alpha beta. Alpha plus beta is equal to 2 plus negative 2 by 5, which is negative 8 by 5. No, positive 8 by 5. And alpha beta 2 into negative 2 by 5, negative 4 by 5. Alpha plus beta we got 8 by 5. Alpha beta we got minus 4 by 5. Now, what is minus b by a? What is minus b by a? Minus of minus 8 by 5, which is 8 by 5. Okay. Alpha plus beta also we got the same value. And alpha beta c by a, which is negative 4 by 5. So alpha beta is same as c by a. Now what is the relation exists? Alpha plus beta is equal to minus b by a is equal to 8 by 5. Alpha beta equal to c by a is equal to negative 4 by 5. So this is the relation what we can observe in any quadratic polynomial. Sum of zeros equal to minus b by a and product of zeros equal to c by a. Understood, children? So up to here we have seen the last class. Now children, we are going to solve problems basing on zeros of the quadratic polynomial. We are going to solve problems basing on zeros of quadratic polynomial, which is, this concept is very important. Okay, na? Right. Let us go to the first problem on this. Alpha beta are the zeros of 2x square. Alpha beta are zeros of 2x square plus 5x plus k. Alpha beta are zeros of 2x square plus 5x plus k. Okay. Satisfying the relation alpha square plus beta square plus alpha beta is 21 by 4. Satisfying the relation alpha square plus beta square plus alpha beta is 21 by 4. We need to find out k value. We need to find out k value. Polynomials law, problems on zeros are very much important. Problems on zeros are very much important. Okay, children. Now, what is given? Think once. What is given? Alpha beta are zeros of this polynomial. Okay. And another relation is also given in zeros. Relation between these two zeros are also given. Alpha square plus beta square plus alpha beta is equal to 21 by 4. That is also given. We need to find out k value. Okay, now see, alpha square plus beta square plus 2 alpha beta minus alpha beta is equal to 21 by 4. Can I write like that? Here are రాయచ్చా? రాయచ్చైతే ఎందుకు? Why? ఎవరు ఆన్సర్ చెప్పట్లా? alpha square plus beta square plus 2 alpha beta minus alpha beta. This is given and I am doing little bit changes over here. Is it okay? Is that right? Can I do like that? No answer? Can I do like that or not? Given is alpha square plus beta square plus alpha beta is 21 by 4. But what are the changes I am doing? Only one change I am doing. Alpha square plus beta square plus, instead of alpha beta I am writing 2 alpha beta and immediately minus alpha beta. Yeah, good. Now see here children, up to here alpha square plus beta square plus 2 alpha beta, up to here I can write alpha plus beta whole square minus alpha beta is equal to 21 by 4 is equal to 21 by 4. Now I know alpha plus beta is minus b by a because నేను రిలేషన్ చూశాను కదా. I know the relation between zeros and coefficients. Alpha plus beta equal to minus b by a కదా, so I wrote it. And alpha beta c by a is equal to 21 by 4. Now substitute values. What is alpha plus beta? From the given equation it is minus 5 by 2. What is alpha beta? From the given polynomial it is k by 2. From the given polynomial alpha plus beta is minus b by a, that is minus 5 by 2. Alpha beta is c by a, that is k by 2. So I am replacing the values here. Minus 5 by 2 whole square minus k by 2 is equal to 21 by 4 is equal to 21 by 4. Now children, find out the k value. Find out the k value fast. Simplify and find out the k value children. This will be 25 by 4 minus k by 2 is equal to 21 by 4. Now further simplification, 25 by 4 minus 21 by 4 is equal to k by 2. Just interchanging the values. 21 by 4 bring it to this side and k by 2 send that one to that side. Okay. Now 25 by 4 by 21 by 4, 4 by 4. So k by 2 is 1. K is equal to 2. 4 by 4 which is 1. So k by 2 is 1, k is equal to 2. Okay na? A very good problem. Next one. Next question. Find the quadratic polynomial sum of whose zeros? Sum of zeros is 8. Sum of zeros is 8 and their product of zeros is 12. So we need to find the polynomial. We need to find the polynomial, children. What is given? What is given? Sum of zeros is given 8. Product of zeros is given 12. We need to find the polynomial. How to do it? Anyone? How to do it? Yeah. See, sum of zeros is nothing but alpha plus beta. If we consider alpha plus beta as sum of zeros and alpha beta as product of zeros, okay, sum of zeros alpha plus beta, product of zeros alpha beta, okay na? Then the quadratic polynomial is x square minus alpha plus beta into x plus alpha beta. If we consider sum of zeros as alpha plus beta, product of zeros as alpha beta, then the quadratic polynomial is, note down the formula, children, x square minus alpha plus beta into x plus alpha beta, where alpha and beta are the zeros of the quadratic polynomial. Now it is easy now. X square minus alpha plus beta, 8 into x, alpha beta 12. So the result is 4. X square minus 8x plus 12. That's all. 4. Understood? Is it understood, children? Okay, next question. Next question. Find the quadratic polynomial whose sum of zeros is 0, sum of zeros is 0 and product of zeros is -1. Find the quadratic polynomial. Children, do it fast. Sum of zeros is 0 and product of zeros is -1. Find the polynomial fast. Sum of zeros means this is nothing but alpha plus beta. This is nothing but alpha beta. And we have a formula. x square minus alpha plus beta into x plus alpha beta. Now substitute the values. X square minus 0x minus 1. That means x square minus 1. X square minus 1 is the quadratic polynomial. X square minus 1 is the quadratic polynomial. Can we find its zeros, children? Can we find its zeros? What are the zeros of this polynomial? Zeros of the polynomial x square minus 1 is what are its zeros? 1 and minus 1. Very good. We can split this one as x square minus 1 square, a plus b, a minus b. So 0 of this one is minus 1, 0 of this one is 1. So negative 1 and 1 are the zeros of that polynomial. Okay, na? Now next question. Next question. See the next question. Find the quadratic polynomial whose zeros are 2 and minus 6. Zeros 2 and minus 6. Now zeros given. We need to find out the quadratic polynomial. Zeros are given. That means alpha 2 beta minus 6. Indaka varaku ichindi previous problems. Sum of zeros, product of zeros are given. We need to find out the polynomial. Now zeros are given. Alpha is given, beta is given separately. We need to find the polynomial. So whatever it may be, formula is same. Whatever it may be, formula is same. Instead of alpha plus beta, alpha beta given separately. Alpha is 2, beta is negative 6. Substitute the values. X square 2 plus negative 6 into x 2 into negative 6. Now when you simplify this, minus 4x minus 12. So x square plus 4x minus 12. X square plus 4x minus 12 is the quadratic polynomial whose zeros are 2 and minus 6. And from this you can verify the relation between zeros and coefficients also. Okay na? Next question. If x plus a is a factor of 2x square plus 2ax plus 5x plus 10, find the value of a. This is 8th class problem. Not 8th class, 9th class problem. X plus a is a factor of 2x square plus 2ax plus 5x plus 10. Find the value of a. Find the value of a. Today's last question. How to do it, children? How to do it? Any idea? If x plus a is a factor of 2x square plus 2ax plus 5x plus 10, find the value of a. This is the question. How to do it? Yeah. X plus a is a factor of this polynomial, na? Then minus a is a 0 of 2x square plus 2ax plus 5x plus 10. Okay. X plus a is a factor of 2x square plus 2ax plus 5x plus 10. So minus a is a 0. Then we can replace negative a in the place of x. 2 into negative a whole square plus 2a into negative a plus 5 into negative a plus 10 is equal to 0. Why we have to put 0? Why we have to put 0 here? Given negative a is a 0 of the given polynomial. That means when we substitute negative a in the place of x, we need to get the simplification must be equal to 0. So simplify it. 2a square minus 2a square minus 5a plus 10 is equal to 0. These two get cancelled. Minus 5a plus 10 is equal to 0. Minus 5a is minus 10. A is 2. So with this exercise is a 2a exercise is almost done in RS Agarwal. We will go ahead with the 2c exercise tomorrow. Okay, na? Thank you very much. Dhanyavad. Mahaganadhipataye Namaः. Thank you. Okay, bye. Click on the like button, right? Not clicking on like button. 24 are joined, but no likes. Why? "24 likes should be there." Shambhavi, click చేసావా? Neha, click on the like button.